In case you guys missed it, I released the custom game shader with a few updates and tweaks to it. I'm releasing it to the asset store, but it's already on itch.io, so you can get it there if you're interested. It is VR supported, double-sided, comes with some extra effects, and in addition to that, it's a universal render pipeline shader. So if you're interested, you can just buy that asset and enjoy it forever, including updates. But in this video, we're now going to talk about using scriptable objects to construct your game's database for your cards. In Unity, you have a few options for databasing. You can set up a JSON database. You could choose to set up an SQLite database, or you could choose to stick with the scriptable objects. So scriptable objects as a database element have the advantage of them, of course, being able to attach code to them. So in that sense, they work literally like scriptable objects. They can be placed in arrays, and they are pertinent assets that show up in your assets folder over here. So to give you an example, we're going to start by creating a C# script for a card data. I'm going to go ahead and open this in Visual Studio, and this is going to be the first bit of code that we write on the channel. Isn't that kind of exciting? So to get started with creating a scriptable object in Unity, the first thing I do is remove everything that's already in here, because we're pretty much going to do this completely differently. And instead of inheriting from monobehavior, which is attached traditionally to a game object, which gets a transform, which gets updated every frame, this is going to inherit from scriptable object. And you can see that pops up. In this card data, what do we want? Well, we want to think about what's associated with our cards. For sure, we have a name. We have a sprite for the image, or texture for the image. I'm not sure which one I need yet. Spoiler alert. The card has a description. And in our case, since we're working with bootleg Yu-Gi-Oh cards, of course, we have an attack and defense. And just for example, set these as a range from 0 to 999. Now this is all great and all, and you're saying, well, these just look like classes, what's the big deal? Well, the big deal comes when you add this attribute to the top of it, which is create asset menu. And so I'm going to say our menu name is going to be equal to YouTube/card data. Okay, so now with this asset, we've told Unity that we want to make this an asset that we can right click and create somewhere. So now if we go back into Unity and enter our folder and try and create a new asset, if we go into the YouTube, we'll see we have a card data here. So I'm just going to say this is card 1. So in this card 1, you can see we've got an asset with some default values here, and I'm just going to pre-populate this with some values based on existing cards. Okay, so I've pre-populated this with some example data, and this is really just a subset of the type of data you can have inside these scriptable objects. So in my Duelist of the Roses remake, all of the 650 plus cards are individual scriptable objects that I actually created from a spreadsheet via a script. Through these scriptable objects, I also assign them effects, so that no matter what instance the card has, I never have to worry about does it have the proper effects, are the effects for this card validated with the database entry? Nope. The database entry pretty much directly provides the effects, description, and stats, images, and more for the card. So you can think of this as presets for your cards. So in my case, this preset is set up with a name, image, description, attack, and defense value. Your presets could be more complicated than this. I can show you how to use inheritance now with scriptable objects to create a hierarchy that makes sense. So we've got our card data here, and that's great and all, but let's create an abstract class here. I'm just going to name this generic card. And we want to think about what are all of our cards going to have in common. Well, let's think about this in the context of Yu-Gi-Oh cards. Every single Yu-Gi-Oh card has a card type, a card name, a card attribute, and minimally some kind of description and art with it. So those are things that we can put into this abstract class that every single card is going to have. So name, texture, card art, public string, some form of description. I'll also say a public int attribute. Even though we don't have any attributes defined, this will let us define attributes in the future. So now by creating this abstract class, we can also put in any logic methods we need to have. And this also gives us a point at which to override other types of cards from. So for example, we can come and change our card data now to inherit from generic card. It gets all the properties I just removed from this class. Since now it inherits from generic card, all of these properties are now a part of this class without us having to write it. And in addition, anything we write here is valid. So now I'm going to fittingly change this to a monster card. And by doing that, I do have to rename the Unity script. So just to provide some more examples, if I wanted to create a spell card, I would say public class spell card extends generic card here. And the only thing I'd need to add on top of here is a list of the card effects, like so. And then from there, the game logic will determine how to execute each effect. And in my case, my card effects are actually scriptable objects. I took some notes on what types of effects were present throughout all the cards, and I was able to narrow those down to about 20 to 25 classes that have multiple different properties on them that could be configured to create each effect individually through one class. So one class can essentially provide effects for 100 to 200 different cards. Spell cards work similar to effect monsters in the sense that the game logic will determine when and how to execute the effects. The card effect pretty much just defines the effect and what objects it needs to execute. You can see that in our card one we have these four attributes, or these four properties from the generic card class, and in addition the attack and defense values here are populated from our monster card class that inherits from the generic class. So you can just see how generics really play a role in scriptable objects. The awesome thing about scriptable objects is that they are always present in your assets scene, which means they're easy to reference from inside scripts. So to show you how this plays into effect, I'm just going to come here and create a simple card renderer. And in this simple card renderer, I just need it really to have a reference to the generic card that it wants to render. So I'm going to say this is card to render. And then I'm just going to call validate over here, and we're going to keep this pretty simple. So I'm just going to say in our awake, we want to get a reference to a renderer. And I'm also going to set up a material property block here. So I'm going to get component renderer and set up my new instance of the material property block. Okay, so in our validate here, this is going to be called anytime we change our card to render here. So in the simplest terms, we're going to change the art of the card that the shader is rendering through this material property block anytime we change our card to render property. What we want to do first is say mbp.setTexture, and I'm going to say this is card art because I know that's what it's called on my shader, and I want to set this to our card to render dot card art right here. So this is it in the simplest sense. You can set up other elements too, such as card name, card description, attack, defense. All of these can be changed and rendered and updated through this validate method, and they're all bound back to the scriptable object. Okay, so there's a couple tweaks I had to make to the script. First of all, in the onValidate, it's very possible that awake hasn't been called yet. So I'm just checking to see if the material property block or renderer variables are null. If they're null, then I set them up and get the component reference as needed. After that, I'm setting the texture through the material property block and then applying the property block directly to the renderer. By using a property block, we're ensuring that we only need one instance of the material in the scene, which helps with performance, of course. So we could have 30 plus instances of the card with one material, and they all have different variations on frame, border, art, etc., because these properties are tweaked through this property block. And these properties, any property that's exposed to the shader and has a public name can be tweaked through this method. So if I come back, I've made a few more example card asset databases here, And if I try to change my simple card renderer script, you can see that as I change, the card info changes. And in this case, it's just the image. But of course, this could also be other things such as card border. You could have attack and defense variables that are here that are updated. You could have name up here that gets updated every time. You could, of course, have attribute. There's a lot of different things that you could have update anytime this card to render variable is changed the way we have set up. I'm just showing you a simple example here so you can get started on building your database-driven card game. So I hope you enjoyed this simple example on how to use scriptable objects to get started with your database-driven card game. I gotta say, scriptable objects are one of my favorite things that Unity has to offer, as they really make tasks like this easy to work with. And anything that requires any kind of databasing in Unity, I just highly recommend working with scriptable objects for. So, until next time, guys, peace out.